Well, if we can use a polar bear for a polar form, I guess there's also a South Pole, so we can also use a penguin for polar form. And so what we want to find is all the solutions to an equation, and then after we find all the solutions to an equation, we want to convert them to polar form. Okay, so x to the third power equals 125. Again, I can rewrite that by subtracting 125 from each side of the equation. Recognize that 125 is actually 5 to the third power. Pull out our good old friend, right, for the sum or difference of cubes. So instead of u to the third, we're looking at x to the third. Instead of v to the third, I'm looking at 5 to the third. And of course, I always keep my original sign. So if it was x to the third minus 5 to the third, we'll keep that as x minus 5. But then the next time I use that sign, I have to use the opposite. So that's why it says x squared plus 5x. And of course, that last symbol is always positive. So plus 25. Right? Because v squared will be 5 squared. 5 squared, of course, is 25. Of course, the first solution is straightforward. It's just going to be 5. X squared plus 5x plus 25 will not factor. So I'll have to use your friend and mine, the quadratic formula. So minus b becomes minus 5. B squared is 5 squared. 4 times a times c will be 4 times 1 times 25. 2 times a becomes 2 times 1. Of course, that minus 5 will sit there for a little bit. That 2 will sit there for a little bit. It takes a while to figure out what is inside that radical symbol. And of course, our imaginary friend I shows up. And so there is the second and third solution. Okay. That looks kind of cumbersome. Let's see what happens when we convert to polar coordinates, however. All right, there are the three solutions. 5, negative 5, minus 5I root 3 over 2, negative 5 plus 5I root 3 over 2. Egads. Well, the first solution is just really easy, right? It looks like the distance is 5, and we're lined up with 0 degrees. So that one's easy. Let's figure out another one. Of course, I'll call that angle alpha. Negative 5 halves is the distance on the real number line. On the imaginary number line, we've got 5 root 3 over 2. And I just realized that the three solutions I have, I'm actually doing the third solution now, right? Because I'm doing the positive 5I root 3 over 2, right? That becomes the positive 5 root 3 over 2. So I've got to figure out the distance. And surprise, surprise, the distance is exactly 5. And then when we try to figure out the angle for alpha, alpha is just negative 60 degrees. So theta is actually 120 degrees. And again, I've got this out of order, right? I've got that as the middle solution, whereas if you look before, I actually had that as the third solution. It's like, And of course, as I now try to find the last solution, again, surprise, surprise, the distance is exactly 5. And the angle is 60 degrees. Well, that's alpha. But that's 60 degrees beyond 180. So theta is actually going to be 180 degrees plus 60 degrees, which is 240 degrees. So those are my 3 solutions written in polar form after I found them in complex number form. Well, you look at that. Those 3 solutions are on a circle. Right? 0 degrees, 120 degrees, 240 degrees. They're equally placed around a circle, every 120 degrees. And they're all the same distance, right? They've got a radius of 5. Right? They're evenly spaced on a circle. In this case, the radius happens to be 5. And we could have figured that out real quick, right? 5 to the 3rd power is 125. The solutions are 120 degrees apart. 360 degrees in a circle. 3 solutions. 360 divided by 3 is 120. Okay, let's see what happens with this one. Hey, this one actually does factor. All right, it becomes x squared minus 16 times x squared plus 16. This factors a little bit further. Oh, I said, hey, let's check. Right, if you're not quite too sure why that factor works, first, outer, inner, last. All right, so just checking real quick with FOIL. Notice that O and I will cancel. So indeed, that is how it factors. It factors a little bit further. X squared minus 16 will factor into x minus 4x plus 4. The x squared plus 16 does not factor. So I've got 3 equations to solve. First answer is 4. That's easy enough to plot. And of course, that would be 4, 0 degrees if I wanted it in polar form. Next solution is just negative 4. Aha! Now in polar form, I'm still 4 units from the origin, and I'm lined up at 180 degrees. Notice I actually put that as my 3rd solution. Okay, now what are my other solutions? Well, if x squared equals negative 16, x would be plus or minus the square root of negative 16. Of course, square root of 16 is 4, but oops, there's a negative, so my imaginary friend I shows up. So my other solutions are at positive 4i and negative 4i. And hey, those are exactly 4 units from the origin. One of them is lined up at 90 degrees. One of them is lined up at 270 degrees. Again, they're on a circle, right? The radius is 4. The 4 solutions are 90 degrees apart, right? 360 degrees divided by 4 makes 90 degrees. Right? They're evenly spaced around a circle. They're all 4 units away from the origin. They're 90 degrees apart because 360 divided by 4 is 90. Okay, something tells me that this is going to spell out worksheet. Penguin, that looks a little bit too warm for you. You better keep on moving. That beach does not look like Antarctica. It does not look like you're very close to the South Pole there.